Hello, today I am going to discuss about the relationship between the PLC physical input output terminal point energization and the PLC virtual switch and virtual output coil activation inside the PLC ladder logic diagram software. This is a very basic yet very important concept that every beginner should understand before proceed further. Okay, so let me draw a picture so that it will be easier to understand. Okay, for example, this is a PLC, and this PLC consists of input section as well as output section, and of course a CPU. Okay, so this is this center portion is PLC or CPU, Central Processing Unit, or what we call processor, and this section is input and this section is output. As we know, the input section and the output section will have its individual terminal points, right? So let's say this is a terminal point. Sorry for my bad drawing, please forgive me. So for this digital input section, its terminal point for this is 0. Okay, this is digital input terminal point 1, digital input terminal point 2, and so on. Okay, as for these terminal points, this is a digital output terminal point 0, this is a terminal point 1, terminal point 2, etc. Okay, let's say this digital input terminal 0 is connected to external switch, and then another external switch is connected to terminal point 1, another terminal switch is connected to terminal point 2. Let's say this is a normally open, and this is a normally closed, and this is a normally open. So let's say this is called switch 0, this is called switch 1, this is called switch 2. Okay, and this digital output terminal point 0 is connected to external load. Alright, and this one also connected to external load. Okay, for example, this is a light bulb. Okay, I call it light 0, light 1. Alright, of course the actual physical wiring will be more complicated than this drawing. Okay, you will need to connect the external DC or AC power supply to this external load as well as this external switch. Okay, in this drawing I simplify it so that it will be easier for me to explain it. Okay, let's say as for the ladder logic diagram, maybe it is programmed in such a way as shown here. Okay, so maybe this is a virtual normally output switch to another virtual normally output switch, and then to the virtual output coil, and then here another virtual normally closed switch, and then this is another virtual output coil. Okay, note that I use the term virtual because all this instruction is only existed inside the software. It is not the physical hardware. Alright, so this is a normally open virtual switch. This is a normally closed virtual switch. This is a virtual output coil. Okay, virtual switch and then virtual output coil. All right. Okay, this virtual switch is linked to this digital input 0. So its relevant address can be written as digital input colon slot 0. Okay, for this input output section is located in the same CPU module. So the slot is slot 0. Let's say there is another module, maybe digital input module connected to this PLC, and this digital input module will be slot 1. Okay, let's say there is another additional maybe analog output module connected to this PLC also. So this PLC analog output module will slot is considered as slot 2. So slot 0, slot 1 and slot 2 and so on. Okay, so this address for this virtual switch is digital input colon slot 0 slash bit. So this bit refer to terminal point. Bit is the same as terminal point. So this is terminal point 0. Okay, which refer to this switch 0. Alright, let's say this virtual switch is linked to this digital input 1. So its address is digital input column slot 0 slash bit is terminal point 1. Alright, which refer to switch 1. Alright, as for this virtual switch, okay, normally closed virtual switch, which is linked to this digital input 2. So its address is digital input column slot 0 slash the bit is terminal point 2, which refer to switch 2. Alright, so this virtual output coil is linked to this digital output 2. So its address is digital output column slot 0 slash the bit is of course terminal point 0, which refer to the external load light 0. As for this virtual output coil, it is linked to digital output 1. So its address is digital output column slot 0 slash bit is digital output 1. So this is linked to light 1. Okay, so let's say, as we can see from this simplified diagram, this switch 0 and switch 2 are normally open switch. Switch 1 is normally closed switch. So what happened is for switch 1, the actual current will flow through this circuit because this switch is closed. So this actual current will energize digital input 1 internal LED as well as its digital input load. Since the LED 1 is energized, what happened is corresponding virtual switch will be triggered. Okay, so what is the corresponding virtual switch for digital input 1? This one, right? So once its internal LED 1 is energized, this virtual switch 1 will trigger. If it is a normally open, it will be triggered to close. If the virtual switch is normally closed, it will be triggered to open. In this case, since it is a virtual normally open switch, it will be triggered to from normally open to close. Alright. As for this switch 0, because it is a normally open, there is no actual current flow through the circuit for this digital input 0. As for switch 2, even though it is a normally open switch, of course, there is no actual current flow through the circuit to energize the digital input tool. However, since the virtual switch for this digital input tool is normally closed, this is a normally closed virtual switch. What happens is the virtual current can flow through this rung. Okay, so again, I use the word virtual because this is not the actual physical hardware. This is just a software. Okay, this virtual power can flow through this rung to energize this virtual output coil. Okay, so this virtual output coil refer to digital output 1, right? This one, digital output 1. So what happened is, since the virtual output coil 1 is energized, what happened is it will also energize the digital output 1 internal LED. Thus will cause is internal digital output 1 internal normally open switch to close, and this will cause a current can flow through this circuit to turn on the light bulb 1. Okay, so I hope you understand what I'm trying to say. So what will happen is when this when this switch 0 is pressed, so what happens is this switch will be closed and the actual current can flow through this circuit to energize digital output 0 digital input 0 internal LED and its internal digital input load. So once the LED 0 is energized, it will trigger its relevant virtual switch, which is 0, which is this one 0, the digital input 0, to be triggered from normally open to close, and this will cause the virtual current or virtual power to flow through this rung to energize this virtual output coil 0, which is referred to, which is linked to this digital output 0. And because of this virtual output coil 0 is energized, it will also energize the digital output 0 internal LED, and thus will trigger is digital output 0 internal normally open switch to close and cause the current can flow through the circuit and will turn on the light bulb 0. Okay, so I hope you understand for my illustration. Thanks, that's all. Thank you.